I have to tell you about the first time I played an early AI-generated video game.
Oh, yeah.
Yeah, I was wandering down this virtual hallway, and I turned around for a split second, only to find the hallway behind me had completely shape-shifted into a solid brick wall.
Just totally boxed you in.
Exactly. I was hopelessly lost in this fun house of shifting geometry. But that exact shifting walls problem, it is finally solved.
It really is.
Today's deep dive into the research paper MultiGen, editable memory for multiplayer diffusion game engines, reveals a massive breakthrough in creating stable AI-generated worlds.
It's a huge step forward.
It is. But before we look at how MultiGen actually anchors these AI environments, let's thank our sponsor, EmberSilk. Need help with AI training, automation, integration, or software development?
Or uncovering where agents could make the most impact for your business or personal life.
Exactly. Check out embersilk.com for your AI needs. So our mission today is to explore how MultiGen uses external memory to create stable, customizable, real-time multiplayer environments.
And it really is a fascinating leap. For a long time, generative models rendering these virtual spaces struggled with, well, basic object permanence.
Right. If you looked away, the game essentially forgot what was there.
Making shared interactive experiences pretty much impossible.
Okay, let's unpack this. I remember past engines, like Game Engine, struggling with this exact issue. Why did the AI keep forgetting where the doors were the second I turned my camera?
It comes down to something called a visual context window. Past models basically guess the next frame of a game purely from recent visual history.
Oh, so their context window.
Right, what they could actually remember. It was essentially zero outside of their direct line of sight.
Got it.
If the camera wasn't actively looking at a door, the AI had no structural memory that the door even existed.
Which explains the crazy environmental drift I experienced. So how did the researchers behind MultiGen actually fix that?
What's fascinating here is MultiGen's brilliant solution. They stopped trying to make a single neural network do everything.
Oh, like a jack-of-all-trades, master-of-none situation.
Exactly. Instead of forcing one AI brain to remember the entire layout while simultaneously drawing the pixels, they gave it distinct jobs by splitting the engine into 3 modules.
That makes sense, like dividing up the labor. What is the first module doing?
The first is the memory module, which acts as a persistent map. Think of it like a film set floor plan.
Okay.
It doesn't care about lighting or graphics. It just knows exactly where the walls and objects are. Then you have the observation module.
So if the memory is the floor plan, the observation module is the camera lens.
Spot on. It generates the actual high-fidelity visuals based strictly on that blueprint. Finally, a dynamics module updates player movement and feeds it back into the loop.
And to prove this works, they actually use the classic game Doom as their test bed, right?
They did.
How does that blueprint memory actually look in practice?
It is surprisingly simple. Because of that memory module, a user can just sketch a coarse 2D minimap.
Literally a basic top-down layout.
Yeah, literally just a 2D sketch. The system uses that as a constant anchor. It completely removes the burden of tracking global geometry from the visual generator.
Wow.
So the AI reliably generates the 3D first-person perspective, and you can play for long sessions without the layout hallucinating or changing.
Here's where it gets really interesting. Fixing the single-player wall shifting is great,
Yeah.
but the paper didn't stop there. They pushed this into real-time multiplayer.
Yes, because that external memory is decoupled from the visual rendering, it naturally extends to multiple users.
The shared memory acts as a single source of truth.
Exactly. The stats from the paper show MultiGen sustaining 30 minutes of 4-player Doom gameplay.
30 minutes, that's huge.
It is, and it flawlessly handles complex interactions like player deaths and respawns, syncing perfectly across everyone's unique, individually generated viewpoints.
That is wild. Are there any hardware catches to pulling off 4 custom AI viewpoints at once?
There is a constraint to keep in mind. It takes a powerful NVIDIA A100 GPU to pull this off for 4 players at roughly 20 frames per second.
Right.
It is an undeniable breakthrough, but we are still in the heavy compute phase of this technology.
So what does this all mean for you? Imagine a near future where anyone can effortlessly author and share stable digital environments.
It's going to be incredible.
You sketch out a quick idea on a tablet, and suddenly you and your friends are exploring a vibrant, AI-generated 3D world that stays perfectly consistent no matter where you look.
If we connect this to the bigger picture, this raises an important question.
Yeah.
If AI can now sync persistent, real-time generated worlds for gaming, What happens when we use this shared memory tech to generate live, collaborative virtual workspaces?
Oh, wow. Or fully interactive educational simulations on the fly.
Exactly. The applications go far beyond entertainment.
It is a massive step forward for computing. The idea that we are moving from static code to live, shared digital realities gives us so much to look forward to.
We really do.
We have this incredible potential to collaborate in ways we never thought possible and to build entirely new interactive media experiences together. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.